Many SpaceX engineers have advocated artificial gravity, in line with the notion of SpaceX progressively turning science fiction into real life. Yes, that's precisely what we see in Star Trek and The Expanse, and it may be a requirement for the Starship. What will SpaceX undertake to do this? Is it possible for them to succeed? Well, you'll find out in a minute. We've all seen science fiction films in which astronauts board a spaceship and go into space. The crew goes on a journey to the Moon, Mars, or another location in deep space after leaving Earth, and the crew is continually moving about inside their spaceship or space station just like they would on Earth. This is an old story in terms of science fiction. In real life, when you leap into space, gravity is significantly reduced. People in these movies, on the other hand, are constantly parading around as if this isn't a problem. This is because artificial gravity exists in science fiction, even if it does not exist in the real world, at least not yet. This is what Elon Musk is working on. Artificial gravity has long been something that many scientists and engineers have wished to make a reality, although no success has been achieved. Elon Musk aims to alter this with his Starship project, because artificial gravity is vital for a variety of reasons, including some highly critical ones connected to astronaut health and well-being, and this will benefit astronauts that need to go to space for significantly long periods of time. Astronaut Scott Kelly found readjusting to life on Earth quite challenging after spending a year in space as part of NASA's twin study. Before humans reach deep space explorations like the Moon or Mars, where the long-term consequences of low gravity are unknown, mitigation strategies will be necessary to reduce such health repercussions. Anyone planning a mission to Mars should take note of astronaut Scott Kelly's inability to walk after spending one entire year in space. Despite a strict training program and the best medical treatment available in 50 years of space medicine, recovery from prolonged zero gravity continues to be a significant physical challenge. Let's not forget that gravity on Earth is responsible for the form of our bodies. One of the key reasons our muscles haven't retreated and diminished through time is due to gravity. If gravity is removed, our body will recognize that muscles are no longer required to keep us operating correctly. As a result, muscular atrophy happens. For astronauts who spend extended periods in space, rigorous muscle-building programs and steroid treatments are required. If astronauts spend too much time in space, normal gravity may kill them, with bone and muscles breaking down and blood vessels bursting as a result of the rapid pressure shift. There are two factors that can help to reduce the danger of a trip to Mars. The outward journey to Mars is expected to take 120 days, or around 1/3 of Kelly's time in orbit, while Mars's gravity is just 40% that of Earth. These arguments, however, are meaningless when considering that any voyage to Mars will need astronauts to begin punishingly hard labor rather than a long time of recovery from zero-G exposure. Arriving weaker on Mars will be worthless at best and dangerous at worst. The answer is artificial gravity, the production of an inertial force that replicates the effects of a gravitational pull, generally through rotation, is known as artificial gravity. Artificial gravity, also known as rotational gravity, is the appearance of a centrifugal force in a rotating frame, as opposed to the force felt in linear acceleration, which is indistinguishable from gravity according to the equivalence principle. As a result, the first and foremost prevalent proposals for creating artificial gravity are to create spinning ships, similar to the iconic Rotor Carnival ride. Centrifugal force will push the crew and equipment against the vehicle's interior, simulating gravity. To implement this capability, the ship's design must be arranged in such a way that a ring rolls around the ship's long axis. Different centrifugal accelerations can be achieved depending on the spinning speed and ring radius. On the other hand, the Starship was clearly not built with these concerns in mind. The ship's long axis spans 160 feet from nose to tail with a 30-foot diameter. This results in a 15-foot acceleration radius, requiring the spaceship to roll quickly, placing significant strain on the space frame. Worse, the forces would weaken as the crew headed up, that is, towards the center of the rolling spaceship. There would very probably be a significant difference in artificial gravity between the head and the toes at this small radius, resulting in a Coriolis force-induced motion sickness. This method is simply unrealistic. Are you enjoying the video? If you are, make sure to give it a huge thumbs up and subscribe to Space Facts, and hit the bell icon for more. Let's get back to the video. Starships will either produce their own gravity with a specific mechanism or by rotating portions, depending on how realistic a series tries to be. While the former is similar to hyperdrive in that it relies on physics that are either wholly imaginary or theoretical at this time, the latter is entirely possible. Small Stars, a YouTuber, has suggested the Gravity Link Starship, a variant of SpaceX's Starship that will be able to produce its own artificial gravity. Part of the inspiration for the concept came from science fiction. He came up with the concept for the GLS after doing some study on centripetal force. The GLS is essentially a hub ship, like the hub of a wheel, with the cargo bay filled with a truss that unfolds and deploys robotically, thereby serving as the wheel's spokes, as he describes in his videos. It would be placed between the two passenger starships, with which it would communicate for the duration of the 6-month voyage to Mars. The passenger ships would spin around to realign themselves and use their thrusters to provide momentum to the wheel once they were connected. The passenger ships would rotate themselves to face inward towards the hub ship after enough velocity was achieved to replicate Earth normal gravity. The centripetal force caused by the spinning of the wheel would lead everyone on board the passenger ships to feel as though they were being pushed down throughout the rest of the journey. Small Stars not only outlined the system, but also ran the calculations for the truss design and the velocity needed to simulate Earth normal gravity. He calculated that a rotational velocity of 31 meters per second would be adequate for a system with a radius of roughly 100 meters, providing the sensation of 1G and revolving at a rate of around 3 rotations per minute using spin calculator. In layman's words, this is how real artificial gravity may be created. Small Stars is presently working on an updated version of this concept, which incorporates new rotation calculations, a new truss design, and the inclusion of cables to increase the truss's tensile strength. In the near future, he plans to release a third version, which will feature load calculations as well as an animation of the truss deployment and operation. Additionally, SpaceX must contend with a spinning spacecraft, which makes precisely positioning antenna difficult, posing communications issues. The antenna will lose and regain signals as they spin, as the rotation pulls them out of their orientation range. Solar panels, which are far more effective in space, are projected to power the Starship systems. Depending on the nature of the spin and the direction of the panels, maintaining the panels orientated towards the sun to gather energy might be complex with a rotating ship. Dr. Robert Zubrin, a longtime advocate for manned Martian exploration, encouraged anchoring a crew module to the decommissioned launch stage and spinning them around a single center of gravity. While this is not a possibility for the Starship because the launch stage is retrieved on Earth, it does suggest a different strategy, such as launching many ships every voyage. We'll just have to wait and watch what SpaceX accomplishes to be able to produce artificial gravity, since the firm hasn't been very forthcoming about its ambitions, most likely because they're still in the early stages and would prefer private critique than harsh public criticism.